Okay, 4. It's sophisticated sequence construction. It sounds like your for loop finally if you are coming from another programming language, but not exactly. So let's say we want to have the direct product of two sets, well, represented in a vectors. Okay, well, the direct product is just all pairs, all ordered pairs. Okay, and we can sort of do this using just map. So let's do that, and then you will see that this is a bit awkward solution. So I can just create a vector. Right, okay, well, this is a good start. So what I want to do that I want to put 1, 2 and 3 into this one, just conjugate, and the same here. Okay, so that will be I'm going to mapcat it. Mapcat what? Okay, so now I have a function here that will take a vector, so one of these, because I'm mapcatting through this set, and what shall I do? And it's like, well, I still have to create a collection. That's gonna be another map. So it's like, well, we have our third map here, and what this one does, okay, just do this anonymous function here. I'm just conjugating this element. What's that? Well, it is the second set. Okay, well, now it's fine. So I did all ordered pairs. And it's how readable is this? Not really. Okay, and it's, well, okay, let's say this is fine. How about if I ask you to have the direct product of 3 sets? Okay, so that's another layer of mapping, mapcatting. So that's not nice. Although it's possible, this is not good style. But luckily we have 4, which has a very clear syntax for this. So let's say that it's like a lead binding, but it's slightly different. A is coming from this set, 3 keywords, and B is coming from 1, 2, and 3. Okay, so I'm finished with the symbol bindings, and now what am I producing? Well, I'm producing A and B together in a vector. Bang, which one is more readable? Yeah, of course, this one. And I can even do, if I want to have C, that's possible as well. Okay, so it's what 4 does is that it will bind values to A from this collection. Okay, it's just one by one. First, symbol A has the keyword A, then symbol A has the keyword B, and then C. But for each A, it will bind B to 1, then B to 3, and B to 2 and B to 3. And for each such B, it will bind C to high and C to hello. Okay, so as you see that sort of we are going through all values for C. That's the very inside of this loop, basically. Then we're looping through B as well, and then A. Okay, so this is the one that gets bound first. So it's you know, sort of map is a very simple version of this, because well, we don't have the variable, but it's like going through an element of a collection. Yeah, it happens the same. It's just, well, we have access to the symbol and can do more than one collections inside one inside the other. Okay, so this is very nice. There are some extra stuff with for, and that is that, let's say I want to have ordered pairs of numbers, well, it's like from 1 to 4, but I want them in a way that the first one is smaller than the second. Okay, well, here's how I do that. Let's call it X. It's coming from range 1 to 4, and Y is coming from range 1 to 4. Okay, let's just do X and Y. Right, well, okay, these are all pairs, it's in the same way, but it's I don't want to have 3, 2 and 2, 1, for example, because I want to have ascending order. So what can I do? Well, I can, I can write a filter around this and get the ones where the first one is smaller than the second. But there is a lot nicer way to do that, and we can do that here inside 4, and I say that, well, this is true, that X is smaller than Y. Okay, strictly smaller, or, well, I can say smaller than or equal to. Okay, it's that simple. There's another sort of modifier. It's well, let's do that. So I can say that for X is in let's just make it simple, range 3. But now I can put a modifier while X is not 1. Okay. So what is this going to be? Well, I get 0, 0, 0, 1 and 0, 2. So what happens that, well, X gets 0 first, and it certainly, we are going as long as this condition is true. So while X is not equal 1, we do our stuff. Well, sure, yeah, then it's we go through Y values and you generate this. Then X becomes 1, and it's like, okay, so we should stop there, and that's what happens. We just stop the whole thing. Okay, so while when goes through anyway and just checks the condition, while will stop when the condition is not fulfilled. And this one is tricky in a sense that this is location sensitive. So if I do something else here, so I put this one oopsie. Okay, is it going to be the same thing? No, it's not the same. Why is that? Well, because I put it here, so after I have the value for Y, and then I decided whether I should continue this. So not before, I descend into the loop for y, like there. But here it's like, oh, I'm in there, and it's like, well, I can just sort of abandon that loop with y. But then I go back and then continue with other values. So therefore I get 0, 0, 0, 1, 0, 2, and for 2 as well. Okay, that's a bit tricky. So it's like, yeah, I'm a bit uneasy about this one, because it's like you have to do a lot of thinking. It's like, why is this happening based on the location? So it's like, yeah, my advice would be just be careful with this one. And there is yet another simple thing when we do for. Let's do another one. And it's okay, if I want to do something in this for, this went down, yeah, no, like this, okay. I could, I could use a let statement there, but since we often want to do this, there is a sort of more natural way to do it. We can just do it here. Okay, just to sum out the product. So instead of writing here another let statement, we can just do it here. Okay, so to summarize, this is for is for producing some sophisticated sequences when we want to do it in a nice and elegant way, and it's like really it's good for enumerating collections and somehow combining them, and it's a bit like a mini language inside Clojure, because we have these modifiers when, while, and let, but certainly can save us from writing something not so readable. It's here, there's 3 maps together to do something simple, and which would be unimaginably complex if we would need to do 3 sets. We can just nicely do it with 4. So this is quite a useful thing, and useful for writing elegant and readable code.